All right.
You have the clicker if you need it.
Great. Well, thank you so much. This is a new line of research for me, so I'm sorry I don't have a lot of data to share with you today, but I appreciate that the structure of this workshop allows us to talk about midway projects and get feedback from those of you with more experience than I have, so I look forward to that. I hope you appreciate the irony here. I created this slide, this image with the assistance of DALL-E, and I asked it to give me a representation of AI cognition error. And it came up with this beautiful image, except for one thing. Can anyone spot it? Yeah, it can't seem to spell the word abort, and it makes that mistake twice in at least two different ways there. Which is a great segue for me and sort of the red flags we want to be aware of when we're trying to do these kinds of build these kinds of collaborations. So before I go there, I just want to give you a little bit of background of how I got interested in this subject. Recently, with a paper in Scientific Reports, we put together the first comparative moral Turing test, where we presented participants with moral evaluations, written passages from AI and from other humans, where we had asked the AI and other humans to respond to answer questions like, how morally, is this action morally wrong? Why or why not? Bobby hits Jill in the face, or other kinds of actions. And what we found, I should add that participants didn't know that any of the submissions were AI generated. They were under the presumption that they were all human generated, and what we found was that people rated the AI's responses as significantly more intelligent, more rational. They agreed with it more. It was more trustworthy, more virtuous, and the AI was a better person. And so this got me really interested in the question of, if people regard the output of these systems so highly, what role is there and should there be for AI collaboration and high stakes decision making with moral implications? So the domain that we hit upon was emergency medical triage. And what I learned in my early research was that as much as a quarter of emergency cases in the US may be under triaged, meaning classified at a lower level than they should. So those patients not getting the care that they should receive in this emergency situation. But these EM triage protocols are algorithms, fairly simple algorithms. And so it should be a relatively straightforward task to train an AI to learn them. So it raises the question of whether a trained AI model could outperform, say, medical professionals. Now, it turns out last year a paper came out by OpenAI on this subject, where they tested their model, medically trained model, against a sizable sample of medical professionals, physicians, along a variety of different dimensions. And their model almost invariably outperformed the physicians. So obviously there's a lot of limitations and reasons to be cautious about these kinds of results, but they're sufficiently interesting to ask, how far can we take this technology in medical context, for example? One concern here is what I'm calling the AI performance paradox. On one hand, if the AI fails a lot, then that's obviously a problem for patient care, but at least we would be alerted to that quickly and stop using the AI in that way. But as AI performance increases, the tendency is for human performance to decrease, which in some ways is a more sinister problem. A relatable example that many of you have probably come across is GPS navigation. How many of you have been misled by your GPS navigator? It works so well most of the time, but it turns out that because of that, we not only lose our ability to self-navigate on that particular route in question, but there's evidence that our overall spatial abilities are worse because of our high reliance on GPS navigators. So similarly, in other contexts, when AI seems reliable, humans are likely to increase their risk exposure and offload more and cease to monitor for errors. Making matters worse, Sebastian Krugel's results show that people tend to underestimate how much they're influenced. So there's a bad combination there. A great quote from Pierre Vac, which says forecasts, which would now include AI prediction, are not always wrong. They can be reasonably accurate, and that's what makes them so dangerous. But the technology, I'd argue, is not the biggest problem. It's the human factor. So how can we ensure that human-AI collaborations are constructive? Well, I have a seed grant now to explore this, to ground and fine-tune an AI model, a multimodal model, so both video, text, and voice, on standard triage protocols and on medically validated patient cases that are instantiated in a triage training game for medical professionals. We have at this point, and so basically what it does is it plays the game by itself, and we're collecting the baseline score now is about 81% accuracy in identifying the correct triage category, which is a score that I'll show you in a moment. And the game looks like something like this. It was developed by my collaborator, Mark Cicero at Yale, who's an emergency physician and academic. His game has a few different scenarios. In each of them, you have limited time to assess a variety of patients, when we train the model on this, the model is both visually monitoring and also reading text from the screen. And when in the next stage will be paired with a human user, it would also be monitoring the human's voice. So it conducts assessments and then treatments, and then at the end of the sequence, it has to make a decision of what triage level from black to green. So what we want to do ultimately, so first I should say that the baseline score is 81%, but after fine-tuning, we expect that number to get much higher. We're aiming for about 95%, which we're pretty confident we'll be able to do once we feed it the appropriate data, and using a GPT model. And then we want to test whether the AI assistants can improve the score of a human user, in this case, nursing students at GSU, in classifying the triage levels. So here are our predicted results. In the first study with humans, this will be a treatment versus control design, where we'll test the real-time AI assistance relative to a control group that does not get any AI assistance. And so you can see that in the control group, we expect performance to increase gradually across these different sessions. In the AI-assisted group, performance we might expect would increase at a greater rate. But then, in that particular condition, after the fourth round, we want to pull the plug on the AI. And our prediction is that performance is going to drop dramatically, maybe even below baseline. And if it does that, this would be evidence that they had performed well for the wrong reasons. They had come to over-rely on the AI's expertise to arrive at the correct answer, rather than use it as a learning tool to help them make independent decisions. So that's study one, the prediction for study one. And pending more funding, we'd like to do a second study where we manipulate the conversational context so that we could control the degree to which they over-rely on the AI. So I'll just go back for a second. In this first study, we're not imposing any constraints on their conversation with the AI. We're just letting them speak freely and interactively, including, for example, asking the AI for the answer up front before the human has engaged in a reasoning process of their own. But in the second study, we want to manipulate that by, in one condition, requiring the human to undergo their own reasoning and arrive at their own judgment before they're allowed to receive feedback from the AI. And in the other condition, they can get the AI's feedback immediately before they've engaged. So what you see here is those two predictions, that the group in blue relies on AI early and often, and so they perform well up front, but when we pull the plug, their performance is going to go down, and the reverse would be true for those who had the delayed AI feedback, indicating that they're internalizing some lessons that they've learned through that process. The ultimate goal here is to arrive at a set of best practices, ethically informed design solutions that will help to maximize long-term performance, independent of whether you're actually using the model at that time. And so here's just some examples that we might expect to be on our list of best practices. For example, if we find evidence of automation bias or favoritism toward the AI, we might recommend trainees make the initial judgment before receiving the AI's judgment, as I mentioned earlier. There's techniques like fault injection that we can do to sort of deliver clearly wrong answers by the AI so that the human user recognizes that the quality of the AI's answers are not always going to be perfect. We can prompt the trainee to provide a justification for their initial judgment to help them reason through more deeply. And we can require routine manual training without the AI. So a lot of different things that we know are probably going to be good solutions to the problems that we discover, because we've seen those solutions work well in other fields like forensic science and aviation, where those techniques were developed. So that's just a taste of where we hope to go, and alongside that, really wrestle with the ethical questions surrounding all of this. So two of my collaborators are philosophers and ethicists in technology. So they'll be leading the scholarship on what constitutes responsible collaborative design, how accurate and reliable must it be in this context, how autonomous should it be bias-free, or is that even possible or necessary? Or are there certain kinds of biases that should be built in that are actually useful? How transparent must it be, and so on. So that's the direction we're headed. You'll have to stay tuned for actual data on this, but in the meantime, I welcome any questions and thank you and my collaborators.
Questions for the speaker? Hello. Cool talk. So you mentioned one possible solution as being injecting AI responses, to questions that are like more clearly wrong, right? To kind of allow humans to realize that like the AI is fallible, essentially. Do you see like any? Can you imagine any? Like at face value, that sounds like kind of a striking thing, or perhaps problematic in some ways, especially if we're talking about in a medical triage setting. If we're talking about like using this in an applied setting where we're injecting purposefully, worse AI responses that could lead to maybe long-term benefit, but short-term detriment.
Thank you.
I don't know. Like,
that's a fair point. There are ethical and practical questions about intentionally delivering incorrect medical information. Now, for now, we're doing this in a training setting, but of course, you don't want them to leave the room thinking that that information was correct. And so the minimum that we hope to do is to test their knowledge and debrief them thoroughly to make sure that we're not sending them out the door with the wrong information. But still, psychologically, there's no guarantee that what the long-term effects of that would be. And so I take your point that that's something that we'll need to be thinking a lot more about.
Let's thank the speaker.
All right, thank you.